Good evening, everyone. My project is on basically the whole idea. Okay. Basically, the whole idea is to try and get fuel from plastics. And in the previous presentation by Lloyd, Denver, and Nadine, they were complaining about the plastic waste we have in the sea. And it's estimated that at some point in time, the plastic waste in the sea will be more than the aquatic life we have in the sea. So I'll give a basic overview of the project from the start. We know how ubiquitous plastics are. They are everywhere. From the time you wake up, your toothbrush, your soap dish, everything you have is made of plastic. And you wonder why, right? Why are they everywhere? Basically, it's because they have some good qualities. They are light in weight, they don't rust, and all of that. So that makes them like more preferable than a lot of other materials. But then, in as much as they are preferable, they also create a lot of problems. And some of those problems are that actually every plastic that has been made, if it has not been recycled, then it still exists. It hasn't disappeared. It still exists. Because they take a long time, about 100 years, some as long as 400 years to decay. So every plastic that has been made, if it's not been recycled, then it actually still exists. Yeah. So the whole aim of this project is to try and figure out what we can do with the waste that we have. I mean, basically in Ghana, for instance, at the moment we are battling with how to solve our plastic waste problem. We find them in our gutters and drains and stuff like that. So the whole idea of this project is to try and see if we can get something meaningful out of the plastic, okay, which is a waste. So we want to use that waste as a raw material or as a resource, okay, to do something workable. And the whole project, I'll skip all of these sites. It consists of a furnace. This is the completed furnace, which is just a cylinder with POP mold inside, and then a blower, and then a pyrolysis reactor, and then there's like the partially complete setup. Yeah, same. And then there's like the complete setup. So the complete setup comprises of the furnace and then the pyrolysis reactor. So what we are going to do is actually pyrolyze plastics. Okay. So now there's a very sharp distinction between burning plastics and then pyrolyzing them. So when we want to pyrolyze plastics, what we want to do is we want to break them down into smaller pieces in the absence of oxygen. But then when you burn it in the presence of oxygen, that's when it becomes poisonous, right? So we are using a pyrolysis reactor, which is this small cylinder here, insulated with ceramic fiber and with a piping connected, and then the furnace. And this is the first run. It's actually a video of like what the result of the work was. And I don't think it's going to play. So yes, but basically, interestingly, when we did the pyrolysis, what happened was we ended up getting some gas, which if the video worked, you would have seen the gas burning. We just flared the gas. So the gas was just coming out, and then it was just being flared over there. So it showed us the potentials that pyrolyzing the plastics have. In some people's work, they've managed to condense it. Mine doesn't have a condenser at the moment. It's just the gas. But if you condense the gas, you end up getting the fuel. It's just a mixture of diesel and petrol and gas, kerosene and stuff like that. And that's the whole idea of the project, to be able to convert the waste into something meaningful or useful like fuel. Thank you very much.